Howdy, folks. You're tuning in to Lesson 15 of Algebra 2 Distance Learning with Hotard. This is the last lesson of the school year. Boo-hoo. Yeah, I'm sure you're sad. With the closing of this lesson, it starts the unofficial beginning of summer. All right, but we're not quite there yet. So hold on to something. It's going to be a bumpy ride. Today, we're going to be learning about geometric sequences and series. This video is on geometric sequences and series. The past two lessons we've been working with arithmetic sequences and series where we were adding or subtracting the same number each time, the common difference. Geometric is where we're multiplying or dividing by the same amount each time. We'll call that the common ratio. All right, so three things we're going to be doing today. We're going to be identifying the common ratio for a geometric sequence. We're going to be using a formula to find the nth term in that geometric sequence, and we're also going to be finding the sum of a geometric series. All right, so again, geometric sequence, it's a pattern with a fixed amount is being multiplied from one term to the next. We call that fixed amount R, the common ratio. That's what we're multiplying by the first term. So first of all, just find the common ratio. Looking at example 2, 3, 18, 108, 648. I want to know what's being multiplied each time. Now you should already know 3 times 6 gives you 18. But if you didn't know that, you could always just divide any term by the term in front of it. 18 divided by 3 gives me 6. That's my common ratio. R equals 6. So number 3, now notice this one, it's positive, negative, positive, negative. All right, if I divide negative 3 divided by 1, what's that mean for R? It's negative 3. When R is a negative number, when you're multiplying by a negative, every other number is going to be a negative. All right, number 4. This time, we have fractions. Look at the bottom. All right, look at the bottom. What's happening to the bottom numbers? They're multiplying by 6. And that's the denominator. That means R is going to be 1/6. And also, you notice this, negative, positive, negative, positive. That means R, the common ratio, is negative 1/6. That's what we're multiplying by. And then one more problem dealing with this. All right, this time it's not multiplying, it's dividing. It's dividing by what? 4. All right, 16 divided by 4 gives you 4. 64 divided by 4 gives you 16. So that doesn't mean R equals 4. If it were flipped around, R would be 4. Since we're dividing by 4, it's the same thing as multiplying by 1/4. So R is going to be a fraction if you're dividing to get to the next number. R equals 1/4. Okay, so next, before we do anything new, I want you to open up that practice page I posted on Moodle. Just try the first 4 problems. Make sure you can do that. Okay, and now we're going to get into some formulas. The past 2 videos have been running kind of long, so I'm just going to give you the formulas to save a little bit of time. Explicit formula for a geometric sequence, that's this. That's A of n equals A1 times R to the n minus 1. Remember, an is the last term, the term you're looking for. A1 is your first term. R, we just did that, common ratio. N is the number of terms. Okay, so next thing we're going to do is going to be asking us to find the 8th term using that formula. All right, so in number 7, I could tell A1 is negative 4. N is going to be 8 because that's the 8th term I'm looking for. And then what's R in this problem? What is it multiplying by? Positive or negative 3? Multiplying by positive 3. R equals 3. Negative 4 times 3 gives you negative 12. Negative 12 times 3 gives you negative 36. So using my formula, I want the 8th term. A of 8 equals A1, which is negative 4, times 3 to the n minus 1. So to the 8 minus 1, or to the 7. Now, these numbers get big pretty fast, so you're definitely going to want a calculator to work these problems. All right, negative 4, parentheses, 3, exponent 8 minus 1, or exponent 7. Now, negative 8,748. All right, unlike arithmetic where we were adding and subtracting the same amount each time, geometric, since we're multiplying, the answers wind up getting pretty big. All right, number 8. We don't have A1. We have A3 this time. It's negative 100. I need and I want to know the eighth term. I need A1 to use my formula. If I know the negative 100 is the third term, and I know each time I'm multiplying by 5, what can I do to get A1? I could divide by 5. How many times? 2 times. If I divide by 5 once, negative 100 divided by 5, that means A2, term in front of that, is going to be negative 20. And then I'd have to divide by 5 again to get A1, which is negative 4. So now I could use my formula. So the eighth term, A8, is going to be the first term, negative 4, times, we know R is 5, to the 8 minus 1, or to the 7. So negative 4 times 5, exponent 7, going to give me a very big number. It's going to be negative 312,500. All right, so that's geometric sequences, finding the nth term. Now, last thing we're going to look at, geometric series. Remember, series and sequence aren't the same thing. Series is the sum. All right, so the formula for a geometric series is this. S of n, S for series or sum, equals A1, parentheses, 1 minus r to the n, divided by, parentheses, 1 minus r. There's no n minus 1 in this one. All right, it's just 1 minus r to the n over 1 minus r. The trickiest part of these whole problems with the geometric series is just making sure you type it in the calculator correctly. All right, so if you look at number 10, I want the series. I want to know negative 2 plus negative 10 plus negative 50 plus negative 250 all the way to 8 terms. All right, so here's A1. It's negative 2. What's r in this problem? It's multiplying by 5. R equals 5. And then they told us n is 8. So that means the sum of these numbers, S of n, equals A1, which is negative 2, parentheses, 1 minus 5 to the 8th power divided by 1 minus 5. All right, quick thing before we type this in your calculator, 1 minus 5 is negative 4. So yes, you could type just negative 4 on bottom, but on top, this is not negative 4 to the 8th. Do not type negative 2 times negative 4 to the 8th. All right, exponents before subtraction, order of operations. So I would have to type it in exactly as I see it, at least on top. So I would be typing in negative 2, parentheses, 1 minus 5, exponent 8, then close the parentheses, divide by, you could type negative 4, you could just do 1 minus 5 here. It's going to be that big number. Negative 195,312. Negative 195,312. That's the sum of all these numbers up to 8 terms. Next problem. Moving right along. Same type of problem. I know n is 9. I know my first term is negative 3. What's r in this problem? What's the pattern? It's multiplying by negative 3. All right, so this time the sum is going to be A1, negative 3, parentheses, 1 minus r. So 1 minus negative 3 to the 9th over 1 minus negative 3. Now, yes, 1 minus negative 3, that's the same thing as 1 plus 3, which is 4. So again, you could simplify the bottom, but do not try to combine these two negatives. Do not make it 1 plus 3 to the 9th on top. All right, because it's the negative 3 right here is being raised to the 9th. This negative is not. All right, so yes, you can simplify the bottom. You never simplify the top in these problems. You type it in the calculator exactly as you see it right here. So that will be negative 3, parentheses, 1 minus, parentheses, negative 3, close that parentheses, exponent 9, then close that parentheses, divided by, yes, you could simplify the bottom, just make it 4, or you could type it in exactly as you see it. When in doubt, type it in exactly as you see it. 1 minus negative 3. And I'm going to get that. Negative 14,763. All right. Almost there. Stick with me a couple more problems now. Number 12. Do you remember what that thing means? It's sigma notation. It means sum. So the long way of working this problem would be to plug in 1 in for k, do 4 to the 1 minus 1 power, then plug in 2, then plug in 3, then plug in 4, and then all the way till you get to 10, plug in 10, and then add it all together. However, looking at this problem, I know that this is a geometric series because this right here, this is in this form. It's a1 times r to the n minus 1. Now, sometimes when you have these type of problems, sometimes it's going to have a number times a number to the whatever minus 1. All right, if it doesn't have it, then it's an automatic 1. All right, so this is like saying 1 times 4 to the k minus 1. So the quick way of working this problem is just pick out everything you need for your series formula. All right, a1 is this first number right here. It's 1 in this problem. It's not always going to be 1. Sometimes you have like sigma, whatever, 2 times 5 to the whatever. The first number is your a1. This number is your r. 4 is r. And then we need n, the number of terms. Now, if you plug in 1, then 2, then 3, then 4, all the way to 10, how many terms is that? It's 10 terms. So here's n on top. So in this problem, let me just write it out here on the side. N is 10, a1 is 1, and then r is 4. Just picking that straight out of the formula. I'm getting that because it's in this form. It's in the form of the sequence problem. a1, then r, and then however many terms we're plugging in sigma notation, it's that one. So now, let's actually use our formula. S of n equals a1, we said was 1, parentheses, 1 minus r, so 1 minus 4 to the nth power, which is 10, divided by 1 minus 4. And we're going to type that in our calculator. I don't really need to type the 1, but the first one, but 1 minus 4, exponent 10, close that, divided by 1 minus 4, or divided by negative 3. That big number, 349,525. Okay, now last thing we're going to do, look at one real life example. All right, a word problem, yay. In the case of a school closing due to inclement weather, the high school staff has a calling system to make certain that everyone is notified. In the first round of calls, the principal calls 3 staff members. In the second round of calls, each of those 3 staff members calls 3 more staff members. The process continues until all the staff is notified. We want to, first of all, find the number of staff members called during the 4th round of calls, and then, if all the staff have been notified after the 4th round of calls, how many people are on staff at the high school, including the principal. Now, with these word problems, people understand in general how to use the formula, how to plug it in. The hard part that people have a hard time with in these type of problems figuring out, is this a sequence formula or is this a series formula problem? If something's asking for a specific term, what happens on the 5th day, on the 3rd round of calls, on this whatever time, that's a sequence problem. All right, problem A is asking for the geometric sequence. Find the number of staff members called during the 4th round of calls, just during that round. All right, if it's asking for a total, how many total have been notified? How much total money have you made? Something like that. Problem B, that would be a series problem. All right, so sequence, let me just write my formula. S of n equals, oh, not S of n, silly me. A of n equals a1 times r to the n minus 1. So, looking at this problem, I want to know in the 4th round of calls, I want to know a of 4 equals a1, the first amount number. How many people did this start with? Just the principal, so it was 1, times, and it said in the 1st round of calls, he calls how many? He calls 3 staff members to the n minus 1, and then n in the 4th round of calls. So 1 times 3 to the 4 minus 1 can be 27 people, right? Which makes sense because round 1, he's calling 3. Round 2, he's calling 9. Wait, no, that would be 3. I'm sorry. He starts with 3 people. We start with 3 people. And for round 1, we start with 3 people times 3. So it's not going to be 27. He's silly me. It's going to be 81. All right, because round 1, 3 people are called. And then round 2, you'd be at 3 more people, so that'd be 9. And then round 3 will be 27. Then round 4, the fourth round of calls, will be 81 people. All right, 81 staff members. And then the last problem. All the staff has been notified after the fourth round of calls. How many people are on staff? So this one is a series problem. S of n equals, let me just write the formula that we're using. All right, so S of n equals A1, parentheses, 1 minus r to the n over 1 minus r. So A1, first round of calls, they called 3 people. So S of n equals 3, parentheses, 1 minus, r is 3, because each time we call them 3, to the, it says, fourth round of calls, everybody's been notified. So n is 4 over 1 minus 3. So let's just type that in. 3, parentheses, 1 minus 3, exponent 4, divided by 1 minus 3, 120. Now, 120 people are called. However, how many people are on staff, including the principal? The answer isn't 120. You know what it is? It's 121, because 120 people have been called, plus the principal. All right, total 121 staff members. Okay, so y'all go ahead and try those problems on that geometric sequences and series practice page. Again, feel free to email me with any questions you have. I am still checking my email this week. All right, and I'll leave everything up on Moodle. You can continue to use it all summer if you so desire. This is Hotard signing off. I will see you all next year.